let's change directly. So we type, instead of 20, we put minutes. Why minutes? Well, simple, because remember that the times for default for this Flexsim software application is seconds. So if we want 20 minutes, we have to specify that we are changing seconds to minutes. So has been done already. So let's change the MTBF with exactly the same thing, statistical distribution exponential. So let's change the minutes. So let's put minutes between 0 and let's say that. So I put capital. Let's put lowercase. Minutes, comma 1. All right. So apply exponential. Oh, you have two commas, so you have to be careful with the mistakes like this one. Okay. Now let's change MTTR. It's exactly the same, but it says that distribution is uniform between 2 minutes and 5 minutes. Okay. So let's change the statistical distribution uniform and change the parameters for minutes between 2 minutes to 5 minutes. Okay, comma, and let's take the number one. Okay, apply and OK. Now let's change the main stations production. So it says that the rate of failure in the station is 10%. So how can we change it? If we check our information sheet, so we see in here that is telling us that we have to go to flow and output sent to port, and we have to change 90% to port 1 and 10% to port 2. So let's do it in here in our model. So let's go to processor 7, go to flow, output sent to port. So what we have to do is to remember by percentage inputs. Okay, and in these inputs we put 90% are going to port number 1, which is what is port number 1. This is port number 1, and this is port number 2. So 10% are going to the fixing workbench, or where the reparation will be done. In the port number 3 we have 0. Okay, how we can know which these ports are in general? So we have the input ports. The input port is Q4. All right. Central port, we have nothing. We use the central port when we are doing the visual tools. We will check that later again. And look, output ports. Number 1 is going to the sync 11, and port number 2 is going to Q12. Okay, so in this way we are done. Okay, so I will jump the copy for the next 3 processors. Now I have already copied the properties from processor number 7 or first station into the other 3 stations. So I will check this to show you outputs port and percentage 90 to port 1 and 10 to port number 2. So this is already it. Now let's do the fixing of the workbench. Okay, or the fixing workbench. So it says in here that the items with defects or failures are repaired manually in a separate station with a time log normal 35.4, 32 and 0.1, and are returned to the initial queue that feeds the testing station. So let's do that now. So I come here to the processor number 13 or workbench. Okay, well, the first thing that I will do is to change the color, just to have a little bit of a harmony with the rest of our project. Okay, so now it's red, and in the processor in process time, I have to change it to a statistical distribution, and let's use the log normal too. Okay, so let's change it to the specifying numbers, so 35.4 comma 3.2 comma and 0.1. How can I identify this sort of distribution? Well, when you are doing your project, you have to time, for example, every time that the airplane is coming to the airport, so you are timing and creating all the entrance. Then we put that information in an Excel sheet, and I will explain you later how we will find out this sort of distribution, because there are millions of different statistical distributions, but we will deal with that later. Okay, let's do that now. Apply. Well, I have introduced a small change into the computer lab. Number 4 is the capacity of the queue is maximum of 50 units. I have to do that so the module runs smoothly. So let's check that the capacity of each queue is 50 units. Yeah? In this way, the model we will really appreciate what we are trying to do, because if we don't put 50, it will take too long to really show us what is happening with this model. So let's reset and run the model. I will put it a little bit faster. So now that I reached 50 in the queue, they move to the next processor. Okay, and look at that. I can see here all the units that are coming into the system to be fixed. So let's change the view and show names and statistics, and we can see the inputs. Well, this input means all the units that are going from the different stations into the sink. Remember, the sink is all the units that we already have processed or finished, and we have like 200 in here, and 2000 is like 10%, of the units that are good. 10% are run. Let's move now to model 5B. They have 4 types of products. This is the difference with the previous one. Change the color of each product according to its type. Create a dedicated queue for each station, and each station needs a setup time of 10 seconds every time a new type of product arrives. An operator has to do the manual setup of the station. The only task of the operator is to set up the 4 stations. So let's check what I already have done. I have here the operator, as you can see in here, and the operator is connected to each of the stations or processors with the S key. Remember that we have to use the S key. I did in order. I connect the operators. If we can check the operator, I will see all the changes that I have done for this guy. You see the central ports are processor 11, 10, 9, and 7. This is the order that I put on it. Okay. The other thing that I have done in the system is to change the main queue. All right. So remember that it says that the matching item times. So where is that? So this is here in the flow. Okay, and look at that. Output sent to port. Matching item types sent to according to this type. Okay, so to each port according to this type. Send floor items to the output port connected to an object that contains flow items whose item matches the item of the involved flow item. What it means is that, for example, if I'm sending a product